So we're going to do the lessons a little out of order, and I'm actually going to do lesson number 4, which is going to be rewriting some radical expressions. Now there's some warm-ups at the top that deal with invertible functions, vertical line test, horizontal line test. Take a look at the key. If you've got any questions, let me know. I'm going to jump right into the actual notes of rewriting radical expressions with rational exponents. Now, rational exponents, just so you remember, rational is any number that can be written in the form a over b. So oftentimes you will see this as fractional exponents. Now, don't get weirded out about the fractions. It's not going to be hard, I hope. Okay, just kind of follow along. You'll be okay. So here's what we've got. If we've got this expression, you've got b, the b root of x to the a. Now, a couple of things you may or may not notice. Roots have what's called an index. The index is whatever that little number is. And you've got a base, in this case x, with a power of a. Now that can be rewritten where x is still the base, the power of a is your numerator, and your index from your root is the denominator. Okay, so that's what we're going to be working with this transition between radical expressions and rational exponents. So if we look at our notes, we've got this thing that says radical form. Now, first things first, this is a square root. Mathematicians are lazy, all right? Absolutely 100% lazy. There is an index value that we know is sitting here, but nobody ever writes it. And that index value, it's a square root, so it's the root of 2. X has a power that we never write, but it is there, and it's the power of 1. So that's actually what I did is I rewrote this with a radical to a power form. So you've got the square root of x raised to the first, which means the exponential form would be x to the 1/2 power. So the 1 is your power, the half is the index number. So having something raised to the 1/2 power is the exact same thing as taking a square root. That's exactly what it is. Okay, so if we keep going down this list, we've got the radical to a power form here, which is the cube root of x to the first. So in radical form, I could just write this as the cube root of x. That's all I need to do. Let me see if I can get rid of the little extra dot there. I can. And in exponential form, this would be x to the 1/3 power. So power of 1, root of 3. I'm going to keep going. We've got the 4th root of x to the 7th. So this would be the 4th root of x raised to the 7th power. And so in rational exponent form, this would be x to the 7/4. So power of 7, index of 4, index of 4. That's how those work. Now, if I give you the fractional exponent, x to the 3/4, you can reverse the process. So in this case, we would have the 4th root of x raised to the 3rd power, which could also be rewritten as the 4th root of x cubed. Okay, so all 3 of these are completely identical. You could put equal sign between them, and that would be accurate. A couple more here. If we've got x to the 2/5, let's go ahead and rewrite that. This would be the 5th root of x squared, or you can do the 5th root and the x squared in the inside. This order doesn't matter mathematically. Powers and roots are on the same level of your order of operations, so whether you do the power first and then the root, or the root and then the power, doesn't matter. All right, last set in this one is just if you have the 5th root of x, this would be the 5th root of x to the first. So that would become x to the 1/5 power. Now, the one thing I want to caution you about here is you can have a coefficient in front of a root. So 3 times the square root of 2. Okay, you'll notice 3 square root of 2. This expression is very different than the cube root of 2. So make sure that your coefficients are different than your index values. One of the things that I've seen students do in the past is they actually write the 3 inside, like really inside the root symbol to make it obvious that this is the root, so that if this were to have a coefficient of, let's say, 5, then again, it's very obvious this is 5 times the cube root of 2. But whatever you do, make sure the notation works, because I promise, okay, if you write this 3 times root 2, but you were supposed to have written the cube root of 2, these are very, very different, and mathematically this would not, these are just aren't the same, all right? So just be careful. Don't get mad at me if I mark something wrong or make a notation comment. Make it clear what your index number is versus your coefficient. All right, we're going to do a little practice here. All right, rewrite each expression in radical form and as an expression with a rational exponent. All right, the cube root of x. So we're going to do the cube root. So that's actually what we were just talking about, cube root of x, which would be equal to x to the 1/3 power. Okay. Part B is the cube root of x squared. Now this has multiple ways to write it. So you could do the cube root of x quantity squared. You could do the cube root of x squared, and this is all equal to x to the 2/3 power. Okay, so that's all part B there. Number 5, rewrite this whole mess with rational exponents. So I'm going to zoom in on number 5 here. So we've got our index. We know it's 7. X and y both have exponents. What we don't have is 3 doesn't currently have an exponent, at least not written. Mathematicians are lazy. There's a 1 there that we just don't write. So if we're going to rewrite this, this would become 3 to the 1/7, x to the 4/7, y to the 9/7. Each piece, each part here, the 3, the x, and the y, each get their own fractional exponent. And each one of them has a denominator of 7 here because they're all dealing with the root of 7. Now, part number 6 here, we've got denominators of 7, which means that our root is, we're dealing with the 7th root. And now I just want to collect up what's left. So I've got 5 to the 1st. So if you want to write 5 to the 1st, you can. I'm going to be lazy and just leave the 1 power of 1 off. I've got x squared and y to the 4th. So that is the final answer for number 6. And just in case you were curious, that was the final answer for number 5. All right, I'm going to go ahead and close the video here. I will pop up answer keys onto Canvas. So if you've got any questions or concerns with any of the rest of the problems or any of the review problems, please